Hello everyone, my name is Olivia Wu and I am going to show you how to draw a Bohr diagram. It is not a diagram to draw when you are bored, but a diagram proposed by Niels Bohr. As an example, we are going to draw the Bohr diagram of yttrium because its atomic symbol is Y, and why is usually the first question scientists ask to discover more about the world. To draw the Bohr diagrams, we need to find out several things. The first thing is the number of protons. As you can see from the periodic table, the atomic number of yttrium is 39, which is the number of protons it contains. The second thing is the number of neutrons. To find out the number of neutrons, you need to round the atomic weight to the nearest tau number, then subtract it from the number of protons. The atomic weight of yttrium is 88.9, which is approximately 89. 89 minus 39 is 50, therefore the number of neutrons is 50. The third thing is the number of electrons it contains. Since it is a neutral element, the number of electrons equals the number of protons. Therefore, there are 39 electrons. Next, we need to find how many electron shells there are. The number of electron shells is the period number of the element. If we count from the periodic table, yttrium is on the 5th period, which means that it has 5 electron shells. It is not required, but we can also find the number of valence electrons there are in the valence shell. The family number of the element is the number of valence electrons there are. If we count from the periodic table, yttrium has 3 valence electrons. Once we know these numbers, we can start drawing our Bohr diagrams. To draw cleaner and rounder rounds, I used a 10-cent coin, 25-cent coin, $2 coin, bottle cap, and a candle for the first, second, third, fourth, and fifth shell respectively. Since I know that there are 5 shells, I started drawing from the 5th shell for a more accurate position. Then I just drew the nucleus by hand since I couldn't find anything that is round and smaller. The first electron shell can hold up to 2 electrons. The second electron shell can hold up to 8 electrons. The third electron shell can also hold up to 8 electrons. The fourth electron shell can hold up to 18 electrons, and the fifth electron shell can hold up to 18 electrons. In the nucleus, there are 39 protons as calculated before. You can represent it using P, and 50 neutrons represented using N. Since the first electron shell can hold up to 2 electrons, you can draw 2 points to represent it. Electrons are usually in pairs, so the points should be together, but it is not required depending on your teacher. Then, similarly, there should be 8 points on the second and third electron shells, since they both can hold up to 8 electrons. The fourth electron shell should have 18 electrons, and the fifth shell should have 3 electrons since it is the valence shell, and as calculated earlier, there are 3 electrons in the valence shell. Do not forget to put the symbol Y for yttrium. Voila! You finished drawing a Bohr diagram. This Bohr diagram should contain 39 electrons. To check, you could add them up. 2 plus 8 plus 8 plus 18 plus 3 equals 39. You did it! Now, I am going to show you an example for an anion. An anion is an ion that is negatively charged. As an example, I will use a bromide anion. Just like before, we need to know several values before drawing the Bohr diagram. The first thing is the number of protons. You find it the same way as before using the atomic number. So it's 35. The second thing is the number of neutrons. This is found the same way as before, subtracting the number of protons from the rounded atomic weight. Therefore, it is 80 minus 35, which equals to 45. The third and final thing is the number of electrons. Since it is an anion with one negative charge, there should be more electrons than protons. Therefore, you add 1 to the number of protons to get the number of electrons, which is 36. To find the number of electron shells I need, I first subtract 36, the number of electrons, to 2, since I know the first shell can only hold up to 2 electrons. Then I find out that there are still 34 electrons left to place, so I subtracted by 8, then 8, and then 18 until nothing is left. As you can see, I should use 4 electron shells. Then, just like before, I drew from the 4th electron shell since I knew that I needed 4 electron shells, and then moved into the 3rd, 2nd, 1st, and the nucleus. The Bohr diagram of an anion should be similar to what we drew before of a normal Bohr diagram, but with more electrons. As calculated before, we have 35 protons and 45 neutrons. We represented using P and N inside of the nucleus. We know that the first electron shell can hold up to 2 electrons, so we draw 2 electrons in the first electron shell. And then we move on to the second electron shell with a maximum of 8 electrons, and then the third electron shell with also a maximum of 8 electrons. Now we have 18 electrons and we still need 18 more. So we move on to the 4th electron shell, which can also hold up to 18 electrons. So after we fill the 4th electron shell, it would be full. Do not forget to put the title on top, which is Br- for the bromide anion. There you go, this is an anion Bohr diagram. However, there are not only anions in the world, but also cations. Cations are the opposite of anion. It is an ion that is positively charged. A cation is usually a metal. As an example, I will use an aluminum cation with a positive 3 charge. Again, we need to find out the same things as before drawing the Bohr diagram. First, the number of protons. So as you can see in the periodic table, aluminum is here with an atomic number of 13. Therefore, the number of protons is the same, which is 13. What is the second thing? Do you remember? Well, the second thing is also the same thing as before, the number of neutrons. Again, the number of neutrons is the rounded atomic weight minus the number of protons, which is 27 minus 13, which equals to 14. So the third thing you need to know is the number of electrons. The number of electrons, since it is a cation with a positive 3 charge, the number of protons should be greater than the number of electrons. So 13, and it has a positive 3 charge, so it should be it should have 3 more protons than the number of electrons, so 13 minus 3 equals 10 electrons. Then for the number of electron shells, we know that we have 10 electrons, so imagine putting 2 electrons in the first shell since it can hold up to 2 electrons, and then we have 8 electrons left, so we put the remaining 8 electrons on the second shell, which give us no electrons left. Therefore, we only need 2 electron shells. The same as before, we draw the 2 electron shells that we need. Once we have the numbers, it would be very easy to draw the Bohr diagrams. You just put the numbers you calculated before, 13 protons and 14 neutrons, represented by P and N. And then you draw the electrons. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Do not forget to put the atomic symbol, which is Al, with a positive 3 charge represented by 3+. Thank you for watching and bye bye.